This webcast continues the discussion of the lab, Conservation of Momentum. We are in part 1, looking at explosions, and I'm at step 10. So step 10 of this lab report says that in order to analyze what the data that we've taken means, we need to find these two ratios, which we will use as our independent and dependent variables. The independent variable that we're using is the ratio of the cart masses, and I'm defining that ratio as the mass of the blue cart divided by the mass of the red cart. The dependent variable is going to be the ratio of the cart speeds, and I do mean speed. I know that in our table we recorded velocities, but we are going to use the speeds in this ratio. Okay. So the first step in number 11 says let's by hand calculate these two ratios for the first row of the data table, and then we're going to create a formula in the Excel file to calculate them for every row. Okay, so the independent variable is the ratio of the mass of the blue cart divided by the mass of the red cart. Now in the first row of my table, both of the carts had the same mass of 0.5 kilograms. Okay, and so that would be 0.5 kilograms divided by 0.5 kilograms. Well, that's just one. And notice that my units have canceled here. I had kilograms over kilograms, so this quantity is dimensionless. So in this particular activity, my independent variable is dimensionless. As the dependent variable, I need to take the speed of the blue car divided by the speed of the red cart. Okay, but I really just have velocities in my table. The difference, speed is the magnitude of velocity. Right? Velocity may be positive or negative because the sign tells you the direction of motion. If it is negative, it's moving in the negative direction. Speed is always positive. And so really what I need to do is just take the absolute value of the velocity of the blue cart divided by the velocity of the red cart. By taking the absolute value, I'm essentially converting those velocities to speeds. And so that's going to be, let me go back and look at my table, my blue cart had a speed of negative 0.6 and my red cart had a speed of positive 0.6. Okay, so it's going to be the absolute value of negative 0.6 meters per second over positive 0.6 meters per second. And so once again, that's going to equal 1 for the first row of the table. And once again, my units are canceling since it's a ratio. And so the units of this dependent variable, it's dimensionless. Okay, so now I'm going to create a formula in the Excel table to calculate these for every row. Okay, so here, and I've already labeled the ratio of the cart masses as my independent variable. Remember, I changed cart mass, so that was the variable that I had independent control over, and then I recorded the velocities, so that was the variable that responded or depended on the masses. Okay, so my ratio of cart masses, to put this formula in Excel, I click in the first cell in this column. I say equal, that identifies to Excel that this is a formula. I click in the cell that has the mass of the blue cart. If you see up here, it is starting to build this formula, so it has put the address. This is column A, row 14 for my spreadsheet. And then I want to say divide by, so put a slash, and then I click in the cell that has the mass of the red cart. Hit the enter key, and it has now calculated that ratio. And this value matches the value that I got when I calculated this by hand. Then I can just copy that formula all the way down, and it is calculating the ratio of the mass of the blue cart over the mass of the red cart for each row in the table. Okay, now let's put in a formula to calculate the ratio of the speeds. So again, I start with an equal sign to identify that this is a formula, and in order to get a ratio of the speeds, not the velocities, I need to take the absolute value. In Excel, ABS of something will return the absolute value. So type ABS and open a parentheses. Then I want to put the formula, which is the velocity of the blue divided by velocity of the red. So I click in the cell that has the velocity of the blue cart. I say divide by, and then I click in the cell that has the velocity of the red cart. Close the parentheses and hit the enter key. And again, I got a value that matched what I had calculated by hand, so that's good. I'm now just going to copy that formula down the entire column. Okay, so now I have these two columns populated. And it says here to paste a copy of your data table for the cart speeds, the ratio of cart speeds versus ratio of cart masses. So I'm just going to copy these two columns, and I'm going to do a paste right here. Okay, so now I have that table. Now I want at step 13 to make a graph of the ratio of cart speeds versus the ratio of the cart masses. And so I'm just going to, highlight the numbers in those two columns and insert a scatter plot. There we go. Come over here so I can make it a little bigger. Let's get some axis labels. So here on the x-axis is the ratio of the cart masses, and that was specifically blue divided by red. Okay, and on the vertical axis I have the ratio of the cart speeds, and again it's blue divided by red. Okay, and then my title is ratio of cart speeds after the explosion versus the ratio of the cart masses. Okay, so this is a good graph. You can see that it is not linear, it's curved, and so we need to think about what is the shape of this graph. What kind of relationship do we have between these variables? I'm going to go paste a copy of this at step 13, which is where figure 1 goes. Okay, so the next question asks, based on the shape of that graph, explain the relationship between the ratio of the cart velocities and the ratio. There's a typo here, isn't there? It should be masses and the ratio of cart speeds. Okay, so anyway, so let's say that, the graph of the ratio of cart speeds following the explosion versus the ratio of cart masses was curved and resembled an inverse function. An inverse function is where the y variable is some shape factor times the inverse of the x variable. So how do I know that? That's because if I look at the graph, as the ratio of the cart masses gets bigger and bigger, the ratio of the cart speeds is getting smaller and smaller. And whenever you have a situation where your two variables move in opposite directions, as one gets big, the other gets small, That's some type of inverse function. Okay, so therefore the ratio of the cart speeds is proportional to the inverse of the ratio of the cart masses. Okay, so at step 15 it says, okay, what are we going to do to linearize this graph? Why do we need to linearize it? We need to linearize it so that we can find a physics equation. We can write an equation that fits our data. And so since we just said that the ratio of cart speeds is proportional to the inverse of the cart masses, and I'm going to make this blue. So in order to linearize the data, we will graph the ratio of the cart velocities following the explosion versus the inverse of the ratio of the cart masses. Notice here that it said at this point it would be helpful to start to change the ratio of cart speeds to the ratio of cart velocities. Okay, so let's do that, and then we're going to graph it and see if we get a linear graph. So I'll go back to the Excel, and let's see. So I'm going to copy this header somewhere over to the right, just so I've got a place to put it. Okay, so now my independent variable is going to be the inverse of the ratio of cart masses. So in other words, it's going to be the red mass, the red cart's mass divided by the blue cart's mass. Okay, and here, instead of having the ratio of the speeds, I'm going to have the ratio of the velocities. Okay, so I'm going to calculate the ratio of the velocities. So I'm going to have equal, and I'm not going to put the absolute value sign. I'm just going to click where the ratio of where the velocity of the blue cart is, and say divide by, and then click for the velocity of the red cart and say enter. Okay, so now I have the ratio of the velocities is -1, right? Now that I'm not taking the absolute value so that it involves speed, I'm looking at velocities, and I can just copy that down to the bottom of my table. Okay, and then for the inverse of the ratio of cart masses, I'm just going to take the inverse of the ratio we had calculated before. Inverse is just 1 divided by something, right? So I'm going to say equal 1 divided by, and I'm going to click where my first ratio of cart masses was calculated. Say OK. Of course, 1 divided by 1 is just 1, but now if I copy this down, I'll see that for the next one, originally the ratio of the masses was 0.33. Now that I'm taking the inverse, the ratio is 3. Okay, so I really have taken the inverse of that ratio of masses. Okay, let's graph this and see what kind of shape we get. So I'm just going to highlight those numbers and insert a scatter plot. Okay, beautifully linear, which is what we were hoping for. Going to get some axis titles. Because the origin is up here at the upper left corner, the labels for the x-axis are kind of on top of the graph. If you want to change this to make it more legible, more readable, do a right or click on one of these numbers and say Format Axis. And one of the options is to tell Excel where you want to put the labels. So I opened up the drop down under labels, and I'm just going to say put them low. That way, they're not on top of my graph, and it makes it easier to read. Okay, but this is nice. So this is the ratio of the cart velocities after the explosion versus the inverse of the ratio of the cart masses. And so on my x-axis, this is the inverse, right? The inverse of the ratio of the cart masses. So in other words, it's the red cart over the blue cart. And here we have the ratio of the cart velocities. And this was the blue cart's velocity divided by the red cart's velocities. Okay, it's linear. It has a negative slope. Okay, so I probably need to put this in my graph. At step 16, it says include both a photo of the table and the linearized graph. Okay, so I'm just going to, highlight all of this so that I can put it in my report here at step 16. Okay, and so now it says, okay, let's do linear regression so that we can find the slope of this. And so I'm going to go to the Data tab to where it says Data Analysis. And I'm going to choose Regression from this list of tools. First, I need to give it the range of variables on the y-axis, which is the ratio of the velocities. So I highlight those numbers. Then I need to give it the addresses for the things on the x-axis, which is the inverse ratio of the masses. Please get the residual plots and the line fit plots, and then say OK. So here are our results. I'm just going to go to Home, Format, Auto Fit the column width because it crunches all the numbers together, just to spread it out so I can see it well. Let me move these graphs so I can see them. Okay, so this looks good. I got a good fit to my data, and I can see that the slope is -1. Okay, so I'm just going to get all of this as evidence of how I calculated the slope and put this in my lab report. Nope. Here at step 17. Okay, and so now it says let's write a physics equation. Okay, so our independent variable is the inverse of the ratio of the cart masses. So that's the mass of the red cart divided by the mass of the blue cart. And that equals our slope. By the way, our slope is dimensionless, right? If I look at that graph again, there are no units for either of these independent variable or the dependent variable, and so my slope also is dimensionless. Okay, got too many things open. Here we go. So my slope is just -1, and then my dependent variable is the velocity of the blue cart divided by the velocity of the red cart. Okay, so that is the physics equation here, and now it says let's cross multiply this physics equation to derive an equation that involves the momenta, the linear momenta of both the red and the blue carts. So when I cross multiply, I'm going to multiply both sides by the velocity of the red cart. So I would have the mass of the red cart times the velocity of the red cart equals -1 times the mass of the blue cart times the velocity of the blue cart. Okay, so all I've done is cross multiply, and then let me just simplify this because it wants something that involves the momenta of both carts. Well, mass red times velocity red, that is the momentum of the red cart. And the momentum of the red cart must equal the negative of the momentum of the blue cart. And that is what we found. Yes, when we look at our data table here, I see that, right here, the momentum of the red cart was 0.3, the momentum of the blue cart was -0.3. So they are equal but they are negative to each other.